Hi everybody, welcome back. This is Kim. I'm really glad you're here. Today's video is about binary. What is a binary number? It's the language that computers use. What does it all mean? I overheard some coworkers talking about binary recently, and I was kind of shocked that the lack of knowledge about binary numbers. So I thought I would do a video about it. So before we get started, please don't forget to subscribe, and I appreciate it. So anyways, I'm going to explain binary, and I'm going to tell you briefly how to convert to a binary number, how binary is used, etc. So hopefully this will be interesting to you. Okay, so what is binary? Well, binary is a code that represents numbers using a series of zeros and ones. Codes are the language that computers understand. When something is digital, that means that it's using binary code to operate. Digital basically means it uses ones and zeros. Computers simply follow specific and detailed binary code instructions. Whatever the code instructs them to do, that's what they do. They don't think for themselves. Well, some do, but that's another video. How do computers use binary? Well, computers use binary, the digits 0 and 1, to store data. The circuits in a computer's processor are made up of billions of transistors. Each transistor is a tiny switch that is activated by electronic signals it receives. The digits 1 and 0 used in binary reflect the on and off states of a transistor. If an electrical signal is on, then it's a 1. If the electrical signal is off, then it's a 0. This two-state system is well suited for computers' optical and magnetic components. Every number, no matter how large, can be converted to zeros and ones. This is considered base 2. Every word can be converted too, although it is a little more complex of a process, and I'm not going to go cover that in this video. Binary code, strings of zeros and ones, are known as bits. They are organized into groups of 8, known as bytes. So 8 bits equals a byte. So when you convert to binary, this is kind of the chart that I use. There's a few different ways you can do this, but I find this the one that makes the most sense. So 1 bit would be 1, and then you double it 2, double 4, double it would be 8, 16, 32, 64, 128. So you're basically turning on or off each one of these bits. And by doing that, you are creating a binary number. So if it's on, you're putting a 1. If it's off, you're putting a 0. Oh, I put 2 here. This should be a 0 right here. That's funny. Okay. So this is a video that's going to show you how to turn 3 into a binary number. So basically what it does, what you do with this chart, so 3, you pick the largest number that goes into 3. So 2 would go into 3. Doesn't have to be equally, just like 4 is bigger than 3, so we can't use 4. So, but 2 is smaller than 3, so we can turn on the 2. And if we turn on the 2, 3 minus 2 means we have 1 left, so we would turn on the 1. So all of these would be off because they're too big, and the 2 would be on, and the 1 would be on. So it'd be 2 plus 1 is 3. So let's watch this little video here. So 3 equals 2 plus 1. Like I just said, we're going to turn on the 2, we're going to turn on the 1, and all the rest are going to be off. So our 8-bit binary number is going to be 0, 0, 0, 0, 0, 0, 1, 1. So sometimes you've probably seen people with shirts on or bumper stickers that'll say 1 plus 1 equals 3. This is why. 1 and 1 is 3. It's really So anyways, yeah. Okay, so let's move on and do a little bit. Let's do a different number. So now we're going to do 14. So, well, we can't use 16 because that's bigger than 14. So we're going to start with an 8. So we'll turn on 8. So that would be 14 minus 8. So we have 6 left. So we have an 8. We can have one 4, right? So 8 plus 4 is 12. And then we'll have 2 left. So then we turn on the 2. And then we'll have 0 left. So we put the 0 here. So that would be 8 plus 4 plus 2 equals 14. Let's watch the little video. Okay, so remember we can't use 16 because that's bigger. So we're going to start with the 8 plus 4 plus 2. So then we have 0 here, and we're going to fill in zeros here. Our 8-bit binary number will then be 00001110. And that will show the number 14. And to check it, all you have to do is add these numbers. 8 plus 4 plus 2. That equals 14. Okay, so let's move on. Let's do a bigger number, 51. Okay, so 51, 64 is bigger, so we're going to start with a 32. So we're going to turn on 32. We're going to put a 1 there. So 51 minus 32 is 19. So then we can have a 16, and then we're going to have 3 left over. So we're going to have a 1 and a 2. So these will be zeros. 0, 0, 1, 1, 0, 0, 1, 1. Let's watch the video. So remember, you can't use the number that's bigger in it, so that has to be a 0. It has to be a number that's smaller than the number you're converting. 32, 16, 2, and 1. So if you add these together, they equal 51. And our 8-bit binary number is going to be 0, 0, 1, 1, 0, 0, 1, 1. So it's really pretty easy. It's kind of fun once you start doing it. And yeah, it's fun to play around. So that was 51. It's the same process for any number. An 8-bit byte max number is 255. So if you had each one of those all turned on, it would equal to 255. So I'm going to go back so you can see, just so we look here. So if we did 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that would be 255. Okay, for larger numbers, just add another byte. Unlimited amount of bytes can be used. There are tons of online converters you can use to convert from decimal to binary, or vice versa. You can also use the Windows 10 calculator, which is a pretty cool tool. It's built into Windows 10, and it's not just a normal calculator. I'm going to show you. Play with it. It's really fun. Okay, so here's a normal calculator. Looks pretty straightforward. Has all the normal functions, right? You can just do whatever. But if you click this little thing here, it's the menu. You look at all the different choices you have. We're going to choose programmer for the binary. So when you go into programmer mode, you have different options here. Right now it's in decimal. So the decimal number is 0, but then you could click on binary and it would have the binary numbers. But so here we're in decimal now. So I just typed in a random number, 174. Okay. So I typed in 174, and then here it has the binary number for 174. So you can see the bits that are turned on. 128, etc. 32, whatever. So anyways, you can go through and figure out the binary this way. That way you don't have to figure it out on the chart. You can just look it up. So you can also click on the binary right here. And what that does is now it's showing us the binary number here, which is here. And now you'll notice that you can only type in ones and zeros because binary only uses ones and zeros. And it shows you what the decimal equivalent is right here. Also has a hexadecimal, but we're just talking about binary right now. So then now, if you just typed in a random binary number, which was this one that I typed in, the decimal equivalent is 48,534. So this is 1, 2, 4, 8, etc. So you'll just see that it just keeps adding. Whichever ones are turned on, those are the numbers you add together to get this number here. Anyways, the calculator is really a great tool, and I don't think people realize how many different functions it has. Play with it, you know, go in there and play with it. I think you'll find it quite useful. Anyways, easy, huh? Think of binary as a light switch. It's either on or off. The binary code that a computer sees is all just ones and zeros. If you've ever tried programming, you use words and certain syntax, but in the back end, that's converted to ones and zeros so the computer can understand what the programmer instructions say. There are computer languages that run in binary also, but nobody does those anymore, I don't think. Anyways, now you know why 1 plus 1 equals 3. You have any questions? Do you have any comments, corrections to anything that I've said? Please comment below. I love reading the comments, and I like to learn. So if I've said something wrong or if you disagree with me in any way, please put it in the comments. Let's discuss it. Anyways, that's it for today. Hope this was useful, and see you next time.